And we have Pascal, one of our principal data scientists, Kaggle Grandmaster, focuses on computer vision. And today, since morning, we have heard a lot about ChatGPT, LLM, and that's one of the areas that Pascal is focusing on, and he's going to talk about all the amazing things he's working on. Please welcome Pascal. Yeah.
Thank you.
Thank you.
Thanks for the nice introduction. Hello, everyone. Thanks for coming back from lunch. I hope you all are refreshed and ready for the second part of this today's agenda. So I'll be talking about the fine art of fine-tuning large language models. And today we have already announced a few open source contributions where H2O is giving back what we learned and giving everyone the capabilities to build their own stuff. And that's exactly what I want to talk about today. So we believe that AI will boost productivity by at least tenfold in the next years to come. So up to 2021, there was a continuous but slow improvement in automation and productivity. And for example, the productivity in the US has increased by 250% over the last 70 years, which sounds like a good number, but we are very confident that AI will only accelerate this, and by open sourcing AI and by giving everyone the chance to do this, we are truly democratizing the way AI is being used. So in 2021, everyone had already the chance to use no-code environments, AutoML, all the tools that we are also offering, and they can build and use highly accurate models for the specialized tasks. So let's talk about image classification, for example, for your production line to filter out bad products. But this always needs data, a lot of labeled data actually. So what happened like end of last year and this year was this new emerging field of very, very large language models which incorporate the knowledge of the entire internet even, and they can be expanded to incorporate your company knowledge, your local knowledge. And this makes it easy for use even without any labeled data. So this is kind of where we are heading at. You don't need pre-training or you don't need labeled data a lot. You can just go ahead and use it with one click. And this will only become easier. So we have now chatbots that help you to answer questions and to brainstorm idea, to give you maybe some coding advice, summarization and analysis of larger texts. But at some point we will get there that you only need a one-click solution, and there you have maybe an AI that is generating plus an AI that is a critic. And this critic will then say, well, maybe you're not already there. Give me another improvement on that code snippet that you just gave us. And after this, the automation kind of can take off as this whole AI can be put into an automated mode, and your employees are only supervising the AI as being kind of as you would see co-workers working together. So in case of you have a GitHub repository, you write an issue and the AI is going to solve that issue on its own and make a PR request, and then one of the human programmers is then checking the PR, giving some suggestions. The AI is going to take over again and will improve only on its solution. And another big leap can come from robotics. So if you then turn from that digital world into the physical world, I think this is another big boost that we are expecting in AI development over the next couple of years. So let's build our own LLM in this case. I mean, there are some tricks. If you use APIs that are available in the internet, that are GPT-style APIs, they have the problem that you send all your data to the endpoint, and it can potentially be used for for training their own models or make them better, which is not always a bad thing, but sometimes you want an on-prem solution, and in this case, we can help you. So the building steps for getting your own LLM are actually three major steps for the actual LLM, and then 2 more to make it usable. So you have a foundation model as a baseline, one of these huge models trained on the entity or the entire internet in an autoregressive manner, so it's always predicting the next token. You train it on large text like Shakespeare and everything, and it's kind of always predicting the next token then. As this is not really good at question and answering, because it will just, if you give it a question, it could give another question back, and you don't want that. You want to actually answer a question, an answer to your question. So in this point, we are stepping in and offering our fine-tuning solution. So you only have a small data set of well-curated data following that specific style that you want to teach your model, and then also train in an autoregressive manner again, but teaching specifically that style to the model. And you can improve on that in a third step, which would be reinforcement learning aided by human feedback. So that's what I was referring to earlier. Having a critic trained is much easier than the model itself or the generating model. So you can have that in a loop, have that critic being trained by human feedback. So you would say, this is a good response, this is a bad response. It's also much easier for humans to make these kind of data sets as compared to writing good answers themselves as training. So then you train the model in a loop with a critic and only improve on its capabilities. And as I said, to truly make use of these models, you also want to incorporate a database and memory for it, because you don't want to retrain your whole model every time that you're changing something with your data. So let's say you want some chatbot answering questions about your documents, about the documentation of a new product that you have, and features are going to be added, API is going to be changed, so lots of things in motion. And as you don't want to retrain it every time that you change a little bit, you want to have a database where it's getting these answers from. And this is a whole other story, and I'll come to that later. And then there is also memory, because if you ask a question once, you maybe want to refer to it later and ask a follow-up question, and it should make sense out of it. So let's go to another slide of showing how the large language model is here trained on this small data set. So you have that foundational model, which was trained on the entire internet, and there may be profanity even in that data, and you want to be sure that it's not following this style that the internet is, or the text that it was trained on follows. So you have your data scientist using a framework, and we will show that later. So this is the LLM Studio in this case. We'll be fine-tuning the training process and by hyperparameter tuning like you're known to. And then you're getting this large language model in a fine-tuned state, which follows exactly what you told it to. And so in this example, a learned prompt and answer style following instructions that you give it. So as our CEO announced earlier, today we are open sourcing H2O LLM Studio, which is exactly that center point where your data scientists can, or everyone actually, can go ahead and train their own LLMs and try what is currently the hot topic in AI and be in that or ahead of that curve. So we enable you to build your own custom LLMs, which can be used on-prem. You don't need to take or to use any API. And we are also open sourcing the largest LLM which is out there right now, of 20 billion parameters, and is available also for commercial use. So the things that you're training here with our pipeline, they can be used for commercial use if you're using the right backbones and the right data set. And we've done exactly this with the 20 billion model, and it got very impressive results. So I'll show the link later. Please check it out yourself and try some prompts. You will be amazed, I believe. So yeah, this is LLM Studio, which is allowing you to fine-tune the own models, so giving you that framework. We are fully open sourcing it with an Apache 2.0 license, which is also allowing commercial use. And yeah, saying again here that we are also releasing the model weights for some of these models, not just the 20 billion one, but we are releasing a full LLM suite of different sizes, so you can use it also on smaller computers if you want to try it. Also with the open source, and again, Apache 2.0 license, so good for commercial use as is. Yeah, to our knowledge, this is the largest fine-tuned OS model to date. Please also join us on Discord, and yeah, make sure to check out the GitHub repositories here. So I don't want to waste too much time of going through the highlights. I would probably just skip this and head right into a demo to show you how you actually use this product. And you can run it on any Linux or Ubuntu machine with the NVIDIA GPU. And I will later even show you how you can run it on any other computer and even from your cell phone by connecting to Google Colab. So we are truly opening this to everyone. We don't want to keep anyone out on this journey of open sourcing our product. So let me head into this LLM Studio. What you're greeted with is a home screen showing your hardware. In this case, I have 3 GPUs here on this machine. It says how many experiments I've already done, as this is a machine I've been using. But usually, yeah, you just go ahead and import your own data set, and we have actually prepared one for you. You can check it out on the GitHub repository and just download it there if you don't have something yourself to get started. And yeah, let me upload it real quick to show. So this is really a UI experience. You don't need any coding experience, and you can easily get started for training or with training some models. So actually, this is a very small data set, as I said earlier. So training is quite quick. Upload it, set your training data frame. You can also upload a validation data frame, and I'll show it also. Follow a prompt answer style. So you always want to train your model giving an instruction, and the model itself should answer by following either the question or the instruction. And yeah, you can continue then. Already get a nice overview, so you see directly if you got everything right for the import, and then continue having your data sets, multiple data sets where you can train from. So as I said, training or fine-tuning is the art of hyperparameter tuning. So we have a huge list of hyperparameters or ways to train the model in a good manner that it's using less memory than you would expect from such large models. This is including low-rank optimization, 8-bit training, so things that help you to fit any model on smaller GPUs as well. So you go ahead, select a data set here for training on. We're training as a causal language modeling, so this is the autoregressive training for predicting the next task and the next token. And then select any large language backbone that is hosted on Hugging Face. And these Eleuther Pythia models, for example, they are allowing commercial use, so you can just go ahead, train your model on top, or fine-tune that model, and deploy it even in commercial usage. We select the train data frame here, and I also have a custom holdout validation set here included. Maybe also only take a small data sample here to make a first test how you would run this. There are a few other things here to set up, so you can even say how you want to structure the data by not only telling where the model or by telling the model that now it's turn to make an answer. It helps to give maybe a separator here, which can be like bot here, so the model exactly knows when to download, when to make its own prediction. And after setting all of this up and also setting learning rate, size of the model, we can run this experiment using the machine that we are connecting here to. And yeah, so this will be queued and then running, and I'll don't want to waste your time by showing this how it's running. Just stop it here and jump into a model that was already trained here. You can see it was rather quick. So this is 0 epochs. So you're actually doing only the validation. But in this case, yeah, this was trained and it was super quick in 14 minutes on a reasonable sized data set. Go ahead. We have the nice UI showing you how the training really was done. So you have your learning rate ramping up. So have a small warm up here in the beginning, then going with a cosine scheduler, and you see how the batch loss, the training loss decreases, and also the validation loss follows that pattern. Boy score is improving here. Boy score is maybe not the perfect score to score these models. So we also incorporate that critic actor validation by asking another LLM to score the model. And this can also be used as validation. Yeah, you can go through the train insights, so even look at what the model is seeing. In this case, yeah, lots of padding tokens can be seen. So we really want to make you use this UI to learn how LLMs are being trained and how you can improve on the process. For validation prediction insights, you can click through the best and the worst samples that have been trained. So in this case, in the training data set, there are a few code snippets, and it seems to be following these quite well. So training, the target text is quite similar to what it's actually predicting in terms of boy score. Yeah, follow the logs here, and then we can even load that model once it's trained, and already have the inference within our app. So you don't need to write your own code to use this model as a chatbot. You can directly go ahead here and ask it something like, what is the capital of India? And then, yeah, it will do the forward pass through the model, including the optimization steps that you have done, and answer with the capital of India is New Delhi. And we can even follow up on that question. As I said earlier, we have the memory functionality within the model. So if you now ask how many people live there, it makes sense out of the question. It doesn't really. It knows that we are still talking about the capital that it just said. But yeah, this is probably an old number then. So this is one of the downsides of using pre-trained models and fine-tuning them. As I said earlier, we need also that database step. And this is some product or another step in employing large language models than in your daily work, because you can't be sure that the answers that are coming from the LLMs without any database are true or are completely made up, as we are also seeing with the larger models. Someone may be writing anything on the internet, and this will be trained then a million times, so it's not true. So what we rather want to have is that learning the style of an answer, learning how to ingest a prompt, making a good format of a well-formatted answer, and by using context that we are providing from another source in terms of, in kind of a database. Yeah, let me also jump into a larger model here. So what we have done here was actually training this 20 billion parameter model on the same data set, and it gets very impressive results which are on par with non-commercial models such as Llama, which is Llama trained on alpaca data. So just copying what OpenAI did. And we do this now all open source and ready for commercial use. So can I ask it something like, what does H2O AI do? And what the larger models tend to do is give rather longer answers than the smaller ones. So this is also something that always needs to be thought of, that you have a trade-off of having large models or slow models, and you need a good resource pool to train these, whereas the smaller models which can be run on a small consumer graphic card, but tend to repeat themselves or make answers that are not really usable. So in this case, I think here H2O AI is an open source AI platform, which kind of covers what we are talking about today. And it provides a lot of services around machine learning, including NLP, image classification, regression, anything. So yeah, this was trained on the internet, fine-tuned with that specific style. And I think it covers pretty well what we said. So I'm not sure. Yeah. Maybe we can continue then with what is next with LLM Studio. So right now we were announcing this fine-tuning steps of large language models, but we don't want to stop there. So this whole open source idea here is to drive the community and to drive this work together and make a real use or make a real competitive product out of it. And we can extend what I said, this fine-tuning step, by incorporating a reward model. This is definitely on the next steps, and also train or give you the ability to train your own foundation models if you don't want to take the open models out there. Give abilities to do data processing and clustering and cleaning. And as I said earlier, one of the biggest issues right now is how you would validate these models, how you would really score them. You can't go through 100 or 1,000 different prompts and answers and always say, okay, this model may be slightly better than the last one I've trained. You want some automatic way of doing this, and this is currently under heavy research. So it's usually best right now to ask another very, very large language model, which should make sense out of the answer, and ask it, does the answer really answer the question, or is it unrelated, or is it bad in this context? So this is something that we are definitely working on right now to improve on, and to even push the boundaries of what's currently possible. I think time's what's the time? I could have go to another slide talking about a bit of this ecosystem of really answering questions in a context of a doc QA. But I will continue with this in a training session that is right after this. So please, if you have interest in training LLMs and fine-tuning them, please join me in the other room, training session 2, and we'll do a follow-up there.
Awesome.
Thank you.